So now we can go through, since we know the group, we understand everything in all the questions I've asked before. So, first of all, I asked, what's the longest, or what's the minimum number of moves I need to solve any cube? 20. It's kind of crazy. We look at something that was on the order of like what? I don't remember, so 43.2 quintillion, and at most we need about 20 moves. If you look in the when you buy one of these fresh out the box, it gives you a little solution guide for how do you actually fix this whenever you've got yourself hopelessly confused. And the answer there, if you sort of work through, it'll take on average about 80 moves to get through. So it's by far not the most efficient. It was very clear that the guy who did it at the beginning was not doing, even though his hands were moving blindingly fast, he wasn't doing 80 or so moves. He was doing much closer to 20 moves. And the people who do these very quickly and compete in them, there are a bunch of algorithms that you can use to sort of quickly move something into a better position. How do you solve something like this? Well, as you think about what is this question actually asking? It's saying, give me an element in my group, an arbitrary one. And an arbitrary element in my group describes to me a cube. So if you give me a shuffled up cube, that's the same thing as giving me an element to the group. And then I can ask, how do I represent that element as a sequence of my basic moves? The up, down, front, back, left, and right. And I ask, what's the longest possible the shortest possible sequence of those that gives me that element to the group? This is called the word length problem. And it's actually a really difficult, and by really difficult, I mean that in a technical sense. It's an undecidable problem for an arbitrary group. If you give me an arbitrary group, I can't even tell you if an element that you give me is trivial. If you just write down a word in terms of generators, I can't tell you if that element is trivial. And I mean like there's no way I can program a computer to tell me is that element trivial for an arbitrary group. For groups that show up in practice, you can't, because you can just sort of like enumerate things. And for the Rubik's Cube group, actually, it's one for which it has a solved word problem. And this is the upper bound. The longest length of a word is 20. So what about the other one? If I keep doing the same move over and over and over and over again, how far until I get back to the start? Well, first off, we do get back to the start. That's maybe not obvious. So you can imagine if I did some really complicated sequence of moves, and then kept doing that same really complicated sequence of moves, why did I get back to the start? Well, that's sort of an aspect in, it's because I'm in a group. And if I have a finite group, there's no possible infinite sequence. There are no sort of periods that don't eventually pass through the origin. The way you say in group theory is every element has finite order in a finite group. And the order the largest possible order, sometimes it's called the exponent of the group, is 1260. And it's actually not a horrible move that does it. So this is a really easy move, especially when you think about the ones that give you, say, like order 3, like the rotate about a single thing, which took an entire line. That was shockingly complicated, but this one is a very pretty simple